Hello, this time I'm going to be talking about file permissions. It might seem like a boring topic, but it's important to understand how they work in Linux. Firstly, I would like us to change into this directory, so example underscore assembly. So go ahead and change into that. And let's do an ls space -l. Alternatively, at least on our server, you can do ll, or you can make your own alias for that. Anyway, let's do ls space -l. And now we're going to see this printed out. This thing right here is going to correspond to the person who owns it. So the username of the person who owns it, that's my username, so I own these files. So I own contigs.fastday, for instance. And this is going to be the group that the file belongs to as well. And where these come into play is over here. These are actually the kinds of permissions that this file has. Now this D right here, this is just for directory. So if it's directory, it's going to have that extra little thing at the start. But if we look past that, these first three are going to be the user's permissions, the owner's permissions. The next three are going to be the group's permissions. And the last three are going to be anyone else's permissions, anyone who doesn't belong to that group or who isn't the user who owns it. So let's take a look at this. I've got an R here, a W here, and then I've got an X down here. Well, okay, this is what they mean. R stands for read, so the ability to read the file, to look inside of it. I think also to copy it, but I'm not sure. Yeah, I think also to copy it. And then W is write, so it allows you to overwrite that file, to make changes to it. Finally, X is execute. For instance, if this was a binary file, I could execute it if it has that X. For directories, execute is important because it allows you to use CD on them, oddly enough. So if you have a directory, make sure you have it executable to allow you to CD. That also means that you could have it so that someone can't look into it. Oh yeah, I'm getting ahead of myself. So those are the three types of things you have to worry about, the R, W, and X. And then let's see here. So this is my permissions. So for contigs.fastday, I am allowed to read it, to do something like more on it, or to copy it. I'm also allowed to write to it, so I can make changes, I can overwrite it. I'm not allowed to execute it, which is fine. It's not an executable. It's not like I want to run it like a script. And this can also be like for safety-wise, you only want to give this permission to things that you trust, things that you know you want to execute, and ones that you think are safe to execute. Now over here are the group permissions. So anyone in my group could also read this. They can see that this file exists. They can also more it or something. They can copy it as well. Now they can't write to it because there's no W here, and they can't execute it. The same goes for other users. They can see it, but they can't do anything to it as well. If I wanted this to only be available to myself and people who belong to my group, well, I could make sure that this isn't checked right here. So that if this was all just dashes, no one would actually be able to see it unless they belong to my group or if they were me. So this is where permissions become pretty useful. Let's see. Why don't we go ahead and take a look at how this works. There is a command that allows you to set these permissions. So it's called ch. It's change. Oh, you know what? I can't remember off the top of my head right now what this stands for. But anyway, this is what will allow you to change the who can do what with this. So, for instance, I can change the file permissions of contigs.fastday. If I don't want other people to see this except in my group, then I'd have to find a way to turn it off. And it's interesting. There are a couple of ways to use this command. I use it using octals. So octals, they range from 0 to 7. That's what the number range is. And it's going to be three numbers that we're going to use that's actually going to dictate these flags right here. So the first one, the first number is going to stand for my user rights. The second number is going to stand for the group's user rights. And the last number is going to stand for anyone else's rights to that file. Now, if I were to set this to 000, it means no one has permissions whatsoever to do anything with this file. I don't suggest saying this. That seems pointless to me. So you're not going to do that. But what you are going to do is you're going to change this around. So it might make sense to have this be 0, because what that tells it is it says that any other user who doesn't belong to my group can't see it, can't execute it, can't copy it, it won't be something they can do anything with. So I can mess with these two because maybe I still want my people who are a part of my group to do stuff with this. Now this is where we can start modifying these numbers. So a 1 here would mean that I have permission to execute this. That might be kind of useful if this was like a binary file. Otherwise, I wouldn't be setting this. A 2, well, a 2 here is going to let you read the file or copy it as well. A 3 is going to actually be a combination because it's 1 plus 2. It's going to be a 3 here. And what that is you can execute it and you can also read it. A 4 allows you to write to it, to alter it. But it doesn't let you execute and it doesn't let you read it. And now this is where the other ones come into play, because now the 5, that would be a 4 plus 1. So that means you could execute it and you can also write to it. Whereas a 6, well, that's going to be a 4 plus 2. So you could read it, you could write it, but you can't execute it. Finally, a 7, they're all set now. So this would allow me to read, write, and execute. So for instance, to kind of change this around a bit, I can turn this into an executable now by having this a 7, and also I can read and write it. And over here, maybe my group can, I don't know. Let's say they can read it, I guess, so that would be a 2. And then I have it so that no one else can see or do anything with it. So, finally, after you come up with the setting for this, which is the first argument, you do need to give it a file. So I forgot to do that. Nice error message for that. So it's going to operate on this, and I'm hitting enter. Now if I do an ls, whoa, it's changed color. Well, the reason for that is that this greenish color is going to correspond to a file that's executable. So if you ever want to run the command, like maybe you downloaded a script or something, it's meant to be run from the command line, you're going to have to make sure that it has execution. It has to be executable. You have to be allowed to do it. So this is where you're going to probably use chmod the most, is just to change it to allow you to execute it. Because by default, when you download something, it's like as a safety thing, you're not allowed to execute it unless you give it explicit permissions. So that's where you'd want to then modify it here. So now I have the rights to execute it. No one else has the rights to execute it, but my group can. And I can actually see that reflected now. They can view it. So right here, RWX, I can now read, write, and execute it based on what I set here. Now they can only write it. Oh, well, I meant to read. Whoops. So I got that mixed up. It was the 1 that's read and the 2 that's execute. So, sorry, it's the 2 that's write. My mistake. 2 allows you to write, and then it is the 4 that lets you read. So I got that order mixed up. It's very easy to mix these things up. I suggest you Google this just to kind of get it down pat. There's another way to set these flags without having to use the number versions of them, but I'm just kind of used to it. You can find that out just by searching about it, and it's using, I think, the plus sign followed by the permissions you want to set or something. But anyway, going back to this, that's how you can set permissions on any kind of file. We could also combine this with that globbing, that wildcard. So I could have done, for instance, this. That would have changed the permission of every single file, so that now they're all executable, readable, writable for me, etc. So that's where this can save time. You can also change everything in a directory. Let's say I wanted to choose to make it so that all the files in this directory have that kind of permission. This is where I would do a -R. That's right, capital R, not lowercase r. I don't know why they chose to make it a capital, but you have to do -R to recursively go into a directory and make it so that all the files have that permission. So just keep in mind this is an option that exists. So when I'm particularly lazy, I can just do that. So there you have it. This is how you can modify permissions. Now, keep in mind, you can only do that with things that you have permission to modify, so you have to be the owner of it. If you want, you can also change ownership, and to do that, you can do chown. And I believe you're only allowed to change the ownership of your file, so you can give it to someone else, but you can't change their ownership to make you the owner. So chown, I could do something like, I don't know, someone who's not me. So someone, genome, and then give it a file. And what chown would do, change ownership, is that it's going to, this little thing right here is going to be who has the rights to it now. So someone would be the username, so whoever this person is. And then this colon here delimits the group. So you don't necessarily have to supply the group, but what this will do is make sure that this person has the ownership, and then this is the group that has ownership as well. So that would be the group rights right here. And then you have to give it the file. -R, capital R, also works for this, along with those globbing patterns. So again, you can kind of speed this up if you want. Now, if you wanted to change someone else's rights, you don't have permission for that. That's kind of one of the safeguards in Linux. You have to be a super user to do that. And that's where the sudo command comes in. You might hear it, you might have heard it before. Sudo allows you to do something that might require super user access. I won't go over that because you're pretty much not going to have that on our server, no offense. But that's something you can use to, for instance, make it so that someone else now has, you can change someone else's files, for instance. But just keep in mind this exists. Also, if you were to do something like, well, I don't know, SU that allows you to change into the super user account, if you were to mess up the password, like I'm just trying to pretend I know a password for this, it says authentication failure, sudo. You can try doing something here too, like chmod. If you mess up the password to sudo, for instance, what's going to happen is that if you keep getting it wrong, oh, okay, it didn't complain. So I was trying to show an example here. Sometimes it might show that this attempt is going to be reported, blah, blah, blah. Well, don't worry. It's not like we're going to come after you if you accidentally use the sudo command by mistake without realizing that you don't have permissions for it. It might say that this thing is going to be reported, but we're not going to be angry at you unless you keep trying to do it. So just keep in mind, if that ever happens, don't panic. It's not like we're going to come after you. It's not like you're on some list. And I guess that's what I was just trying to show, but for some reason, it's not showing it here for me, whatever. So anyway, there you go. Now you know about file permissions, and now I guess you know about sudo as well.